Greetings and welcome. In this video, we have question 5 from the DBE 2022 exam paper, that is Physical Sciences, paper 1. The question reads as follows: arrestor beds are used to help moving trucks to come to a stop when their brakes fail. The driver of a 30,000 kg truck driving down a steep road drives onto an ascending arrestor bed inclined at 20 degrees to the horizontal as shown in the diagram below. So we are given the diagram here. Question 5.1. State the work energy theorem in words. Okay, so the work energy theorem is stated as follows: the net work done on an object is equal to the change of kinetic energy. Okay, I will write it here. The net work done on an object is equal to the change in the kinetic energy. Kinetic energy of the object. Okay, that's how you state the network energy. Now, if you are going to write this in symbols, you don't have to write that. I'm just explaining further here in symbols because we are going to use this formula in a moment. So in symbols, you write this as W net, that is the network, is equal to delta EK. Okay, this, if you look at the formula itself, it somehow describes or it somehow states your work energy theorem in words. So if you just put words here, W net stands for the net work done on an object. Okay, is equal to, so there's an equals here, to the change in the kinetic energy. Delta refers to change in the kinetic energy, EK. We know that change in kinetic energy, we write this as half m V final squared minus V initial squared. We know that kinetic energy is the energy that an object has due to its motion. So stating the theorem, you state it in this way. 5, the question goes on to say that, which leads to 5.2, okay. It reads, the truck with failed brakes passes point A at the beginning of the arrestor bed at a speed of 33 meters per second. Okay. The average frictional force is 31,000 Newton while the truck moves up. While the truck moves up the arrestor bed. So from point A here, we are given that the speed of the car is, we can call that V, 33 meters per second. Then it moves up the bed, and the bed is inclined at an angle of 28 degrees. So ignore the rotational effects of the wheels. 5.2, give a reason why the net work done on the truck while moving on the arrestor bed is negative. So the reason we are going to give here is the fact that when you look at the forces that are acting on the truck, let's say I assume we're going to draw a free body diagram here of the forces. Now when the brakes fail, it means now there's no applied force that is moving up. So there will be two forces acting here. So one is the force which is the frictional force. Remember that frictional force is a force that always acts opposite the displacement, the direction of motion. So there is a frictional force. It will be acting downward because our truck is going up the incline, up the arrestor bed. There will also be another force acting here, which is gravitational force. But for gravitational force, we have to consider the component of gravitational force. So there's a component of gravitational force which is also acting in the opposite direction to motion. That component, we call it FG parallel. Okay, it is parallel to the direction of motion, parallel to the plane. So now we are trying to give a reason here why the truck moves, okay, why the work done is negative. So you find that here the gravitational force and the frictional force, they are all acting opposite the displacement. So you know that any force that is acting opposite the displacement, that force will be will give us a negative work. So we are going to give our answer as the reason being that the frictional force and the gravitational force, okay, are acting opposite the direction of displacement. Which is our delta x. So these two are acting in the opposite direction to the direction of the displacement. 5.3, use energy principles to calculate the minimum length of the arrestor bed needed to bring the truck to a stop. In this section, the energy principles that we are going to use, we are going to revert back to the network, the work energy theorem. So as I've mentioned earlier, that the work energy theorem, you write it as W net is equal to change in kinetic energy. There are two forces, which are gravitational force, which is the parallel one, okay, and we need to find the work done by the gravitational force. Okay, so let's actually write it as this. Okay, we have the work done by the gravitational force, the Fg parallel, plus the work done by the frictional force. So those are the two forces that are acting there. The sum of these forces is our network. Okay, so network being the total work done by all the forces acting parallel to the direction of motion or parallel to displacement. This will be equal to E delta EK. Delta EK, we break it down as half mv m final squared, okay, minus half v initial squared. Okay, we can simply factorize this one and write it as half m v final squared minus v initial squared. Okay, so now let us come back to the substitution. So we are now going to find the work done by the gravitational force. Remember the formula for work done. The formula for work done is work done is equal to F delta x cos theta. Okay, work done is equal to F delta X cos theta. F being the force, and the delta X is the displacement, and the theta is the angle between the displacement and that particular force that is acting on the object. So writing this WFG, the work done by the gravitational force, we are going to write it as Fg parallel times displacement delta X cos theta, because our force here now is Fg. Our displacement is the distance up the arrestor bed that is going to move. So it's what we are going to calculate here. The question says use energy principles to calculate the minimum length of the arrestor bed needed to bring the truck to a stop. So that minimum length is our displacement. Okay, how far up the arrestor bed does the truck go? So we're going to calculate displacement here. So F is our force, delta X cos theta, plus our work done by the frictional force. We apply the formula again. It is the force. Our force now is kinetic frictional force, which is F delta X. Again, it is going to move along the same distance, displacement times cos theta. That is the breakdown of our total network. This will be equal to half m, okay, v final squared minus v initial squared. So now let's put in some numbers. Now there's also one piece of information that we need here before we substitute. We know that Fg is a gravitational component, is a component of gravitational force. Now Fg parallel is defined as mg sine theta. Okay, it is mg sine theta. Theta now is the angle of inclination, because the gravitational force is acting at an angle, so we need to take that into consideration. So breaking this down, the Fg parallel, we are going to write it as mg sine theta. Okay, so write it as mg sine theta. So that is our Fg parallel times displacement. So we multiply that by delta X cos theta plus our frictional force F delta X cos theta. We get the answer, change in kinetic energy, half m v squared final minus v initial squared. All right. So now let us put in our values now. So m is the mass of the truck. Okay, the mass of the truck, as we have read, is 30,000. So 30,000 times g, 9.8 gravitational acceleration, sine theta. Theta is the angle at which the incline is to the horizontal, so that is 28, sine 28. Okay, and this we multiply by the displacement delta X cos theta. Theta is the angle between the force and the displacement. As we have found here, our displacement is going is up the incline. Okay, that is the direction of the displacement. Our Fg parallel is acting in the opposite, so the angle between that is 180 degrees. That is 180 degrees. So our cos is 180 degrees. So that will also apply to the frictional force. So we're going to have cos 180 plus the frictional force, that is 31,000 by displacement, we don't know, cos 180. Frictional force also acts opposite to the displacement. So this is going to equate to, half m is the mass of the truck, which is 30,000, times v final, assuming that it is going to come to a stop, because it says here needed to bring the truck to a stop. So stop means our final velocity is 0. So we're going to have 0 squared minus initial. Initial is the velocity at which it entered the truck. Okay, that is 33 meters per second. So we square that. So now let's add all this. Okay, 300,000 by 9.8 sine 28 delta x cos theta cos 180. If you look at cos 180, if you calculate cos 180, this is simply -1, and also here it will be -1. So we are going to have a negative result here. That's why we said that the work done here is negative, because all the forces are acting opposite. So there's a negative, it's cos 180. So let's work out all these ones here and see what we'll get. Negative 1380 24 comma 6395. This is a delta x, so multiply by delta x. Okay, then we work out this one again, 31,000 by delta x cos 180. Basically this is -1 times 30,000, that will be a negative 31,000 delta x. This will be equal to half of 30,000. I will just put in 15,000 here, multiplying 33 squared. Okay, so I will just put in 15,000 into 33 squared. Okay, it's a big number. That is 16,335,000. Okay, it will be a negative here. I deliberately left a negative there, so it will be negative. So this will be okay, I will just put in the number first, negative 33,000, or let's just write all of it here. Okay, so evaluating that one, we said it's negative 16,335,000. Okay, let's check that if it is correct. We entered right, 16,335,000. Okay, so that is our value. And now we are going to add this one, because they are all like terms, this value and that value. So when I have negative 169,024, so this gives us 169,024 delta x. It will be equal to negative 16,335,000. Now we are going to divide this by delta x by negative 16, so we'll get our delta x will be equal to this negative 16,335,000 divided by negative 169,024.635. I left out that one, 6395. Let's see what will be the answer. So coming here, we are going to have Let's clear that one. 16 million. I'm ignoring the negatives. We know our answer, negative divided by negative, is going to be positive. So 16,335 000 divided by over 169,169,024.6395. Our answer, I'm getting 96.6427. So our answer will be 96.64 meters. So therefore, which means that our smaller the minimum distance, therefore the minimum distance traveled by the arrestor is 96.64 meters. Okay. Now, the next question, the last part of the question, reads as follows. Okay. The diagram below shows this same truck entering a descending arrestor bed, inclined at 20 degrees to the horizontal. The initial speed of the truck and the average frictional force on the truck are 33 meters per second and 31,000 respectively. So which arrestor bed, ascending or descending, will be able to stop the truck in a shorter distance? Explain the answer in terms of the forces acting on the truck. So we have been given two types of arrestor beds. This one is the ascending one, and this one is the descending one. Okay, so I think your guess is as good as mine that the ascending one will be able to stop the truck in a shorter distance. But now we are asked to explain that. If we look at the truck, just take the truck as a free body diagram. When the truck is moving up, here you'll find that there are actually two forces that are acting on the truck. One, as we said, is FG parallel, and the other one is FK. So the fact that we have got the gravitational force and the frictional force acting opposite the displacement. There are two forces acting, so there's a greater magnitude of forces that are opposing the movement. Whereas when you compare here, now if we draw our forces here, as the truck is moving down, the gravitational force now will be acting in that direction, okay, which is FG parallel. So it will be acting down, okay, because gravitational force always acts downwards. The only force that it will be opposing the truck is the FK. Okay, so in which scenario do we find a large amount of forces opposing the truck? It's the ascending arrestor bed. So that's why now here the arrestor bed will, the truck will move a shorter distance up the arrestor bed. So our answer to that question is which arrestor bed, the question is which arrestor bed, ascending or descending, will be able to stop the, so we said 5-4. Okay, it is the ascending one. The ascending. The reason being that both the gravitational force and the frictional force are acting in the opposite direction to the displacement of the truck. Okay, as I've explained here. So